Hello, in this lecture we will find out the length of line segment X. In the drawing we have triangle ABC. We know that side AB is equal to side AE. We also know that BD equals to 3 units, BE is equal to 7 units. And we know that angle BAD, this angle is equal to theta, and also angle EAC equals to theta, and angle BAD is equal to 90 degrees. And we want to find out the value of line segment EC that equals to X. So first of all, we will define angle DAE as alpha. So this angle DAE, is defined as alpha. And from point A, we will go perpendicular to BC. So this angle is equal to 90 degrees, and this angle will be also equal to 90 degrees. And we will define the touching point of the perpendicular from point A to BC as M. In the next step, we will calculate the ratio between the area of triangle ABD over the area of triangle ADE. So here we will calculate the area of triangle ABD. Here the squared brackets is the sign for the area, so it is this sign means it's the area of triangle ABD over the area of triangle ADE. So what is the area of triangle ABD? The area of triangle ABD will be equal to the base of the triangle, that is actually BD, times the height to the base. AM is the height to the base because of the fact that it creates 90 degrees with the base BDs. So it is AM is the height over 2. I will repeat again. The area of triangle ABD equals to the base BD times the height to the base, that is AM, over 2. In the same way, we will calculate the area of triangle ADE. The area of triangle ADE will be equal to the base of the triangle, that is DE, times the height to the base, that is AM. AM is the height to the base because of the fact that it creates 90 degrees with the base DE. So it is the height is AM over 2. I will repeat again. The area of triangle ADE equals to the base of the triangle, that is DE, times the height to the base, that is AM. AM creates 90 degrees with the base DE, therefore AM is the height. So it is the base DE times the height, that is AM, over 2. Here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. What is left from this expression after we cancel 2? What is left, it is actually BD times AM over DE times AM. So we have AM in the numerator and AM in the denominator, so AM will get cancelled. So, and we left only with BD over DE. But it is given us in the question that BD equals to 3 units and DE equals to 7 units. So we found out that the area of triangle ABD over the area of triangle ADE is equal to 3 over 7. In the next step, we will calculate the areas of triangle ABD and the area of triangle ADE in a different way. So now we will take the base of the triangle ABD as AB, and the height to the base will be, the height to the base must create 90 degrees with the base AB. So from point D we will draw perpendicular to AB. This angle equals to 90 degrees, and this angle will be also equal to 90 degrees. And we will define the touching point of the perpendicular from point D to AB as O. Actually, line segment DO is the height to the base AB. Why? Because it creates 90 degrees with the base AB. So we'll define DO as edge 1. So we found out that the area of triangle ABD equals to the base AB times the height to the base, that is edge 1, over 2. I will repeat again. The second way to calculate the area of triangle ABD is to consider the base as AB, side AB, times the height to the base edge 1 that creates 90 degrees with the base edge B over 2. Likewise, we will calculate the area of triangle ADE. We will take side AE as the base, so AE is the base, times the height to the base. The height to the base must create 90 degrees with the base, so from point D we will draw perpendicular to AE. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. We will define the touching point of the perpendicular from point D to AE as K. So DK is the height to the base AE. Why? Because it creates 90 degrees with the base AE. So we will define DK as edge 2. That is to say, dk is equal to edge 2 according to our definition. So the second way to calculate the area of triangle ADE is to take the base as AE times the height to the base, that is edge 2, over 2. I will repeat again. The area of triangle ADE in the second way is the base AE times the height to the base, that is edge 2, over 2. Here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled, and what is left after we cancel 2? What is left? It is actually AB times edge 1 over AE times edge 2. Okay? But according to what is given us in the question, AB is equal to AE. Here AB equals to AE. So AB over AE will be equal to 1. So AB over AE will get cancelled, and we left only with edge 1 over edge 2. So in the next step, we'll calculate the values of edge 1 and edge 2. So what is the value of edge 1? We will focus on the right triangle, triangle AOK. In the right triangle, triangle AOK, we know that sinus theta equals to H1 over AD. Sinus theta equals to H1 over AD. So here we will multiply this equation by AD, and we will get that H1 is equal to AD times sinus theta. So we can write here that H1 is equal to AD times sinus theta. In the next step, we will calculate the value of H2. So we will focus on the right triangle ADK. In the right triangle ADK, we know that sinus alpha is equal to H2 over AD. Sinus alpha equals to H2 over AD. So here we will multiply this equation by AD, and we will get that the value of H2 is equal to AD times sinus theta. AD times sinus alpha. AD times sinus alpha. Okay, H2 equals to AD times sinus alpha. So we can write here that H2 is equal to AD times sinus alpha. So we have HD in the numerator and HD in the denominator, so HD will get cancelled, and we left only with sinus theta over sinus alpha. In conclusion, we found out that according to equation number 1, 3 over 7 is equal to sinus theta over sinus alpha. So here we will cross multiply equation number 1, and we will get that according to equation number 1, 3 times sinus alpha is equal to 7 times sinus theta. So what is the value of alpha? From the drawing, we know that angle BAE from one side is equals to 90 degrees. It is given us in the question that angle BAC, the biggest angle here, BAC, is equal to 90 degrees. So you can write down that from one side, the angle BAC is equal to 90 degrees. But from the other side, angle BAC is also equal to theta plus alpha plus theta. That is to say, angle BAC from the other side equals to 2 theta plus alpha. So from this equation, 2 theta plus alpha equals to angle BAC equals to 90 degrees, we will derive that 2 theta plus alpha is equal to 90 degrees. Here we will subtract 2 theta from this equation, and we will get that angle alpha equals to 90 degrees minus 2 theta. Okay? So here we found out that angle alpha equals to 90 degrees minus 2 theta. Therefore, we can substitute alpha in equation number 1 by 90 degrees minus 2 theta. So we'll do it now and we will get that 3 times sinus alpha, and alpha is equal to 90 degrees minus 2 theta, equals to 7 times sinus theta. Okay, so here we will open the, actually here, according to the trigonometric identity, that sinus 90 degrees minus x is equal to cosine x, we will get that the value of sinus 90 degrees minus 2 theta will be equal to cosine 2 theta. So we substitute sinus 90 degrees minus 2 theta by cosine 2 theta in equation number 1. So actually here 3 times sinus 90 degrees minus 2 theta equals to cosine 2 theta according to this trigonometric identity. And it equals to 7 times sinus theta. We have another trigonometric identity for cosine 2 theta. Actually, cosine 2 theta is equal to 1 minus 2 sine square theta. That is to say, we can substitute cosine 2 theta in equation number 1 by 1 minus 2 sine square theta. So we'll do it now and we will get that according to equation number 1, 3 times cosine 2 theta is 1 minus 2 sine square theta. That equals to 7 times sine theta. So here we will open the brackets on this side of equation number 1, and we will get that according to equation number 1, 3 times 1 is 3, and 3 times minus 2 sine squared theta will be equal to minus 6 times sine squared theta. That equals to 7 times sine theta. Okay? So here we'll add 6 sine squared theta, and we'll subtract 3 from this equation, equation number 1, and we will get that according to equation number 1, 6 times sine squared theta plus 7 times sine theta minus 3 is equal to 0. So here we have a quadratic equation, and the means variable in this quadratic equation is sinus theta. And the general formula for quadratic equation is ax squared plus bx plus c equals to 0. In this general quadratic equation, a, b, and c are the coefficients of a quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula. X is equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Okay? In our specific quadratic equation, the variable that we are looking for is sinus theta, so x is equal to sinus theta. The coefficient A is equal to 6. The coefficient B is equal to 7. And the coefficient C is equal to minus 3. Now we will put the data inside the formula for x, and we'll find out the value of sinus theta that is actually equals to x. So here x is equal to sinus theta, so sinus theta, according to this equation, is equal to minus b. B equals to 7, so minus b is minus 7, plus minus square root of b squared. B is 7, so b squared is 7 squared. 7 squared is 49. Minus 4 times a times c. So it is minus 4 times a is 6, and c is minus 3. All divided by 2 times a, and a is 6, so it is 2 times 6. So actually we found out that sinus theta is equal to minus 7 plus minus the square root of 49 minus 6 times minus 4 times 6 is minus 24, and minus 24 times minus 3 is plus 72, so it is 49 plus 72. All divided by 2 times 6, that is 12. So we actually found out that sinus theta is equal to minus 7 plus minus square root of 49 plus 72 is 121 over 12, and the square root of 121 is 11. So we found out actually that sinus theta is equal to minus 7 plus minus, again the square root of 121 is 11 over 12. So actually we will have here two solutions for sinus theta. The first solution for sinus theta is that sinus theta is equal to minus 7 minus 11 over 12, and the second solution for sinus theta will be that sinus theta is equal to minus 7 plus 11 over 12. Okay? We'll focus on the first solution. According to the first solution, minus 7 minus 11 is minus 18. Minus 18 over 12 is minus 1.5. So we found out that sinus theta, according to the first solution, is equal to minus 1.5. But because of the fact that sinus theta can accept values that is from minus 1 to 1, and minus 1.5 is less than minus 1. Therefore, actually the solution minus 1.5 exceeds the range of the values that sinus theta can accept. That is to say, sinus theta can never be equal to minus 1.5, because the range of values that it can accept is ranging from minus 1 plus 1 and minus 1 to plus 1. And because of the fact that minus 1.5 is out of the range of sinus theta, then this answer is the incorrect answer, so we'll cancel this solution and we'll focus on the second solution. that sinus theta equals to minus 7 plus 11. Minus 7 plus 11 is 4. 4 over 12, so we will divide both the numerator and the denominator on this side of the equation by 4. 4 over 4 is 1, and 12 over 4 is 3. So in conclusion, we found out that sinus theta is equal to 1 over 3. Okay, sinus theta equals to 1 over 3. So in the next step, we will focus on triangle BAE. So I will copy the triangle in a new page and we will analyze the triangle BAE. So this is triangle ABE. Because of the fact that side AB is equal to side AE, triangle ABE is an isosceles triangle. I write it down. AB is equal to AE according to what is given us in the question. Therefore, triangle ABE is an isosceles triangle. And the base of the isosceles triangle, triangle ABE, is BE. BE is the base of the triangle. Is the base of the isosceles triangle, triangle ABE. And we also know that AM is the height to the base BE. Why AM is the height to the base BE? Because of the fact that AM creates 90 degrees with the base BE, or AM is perpendicular to BE, therefore AM is the height to the base. So write it down. Line segment AM is the height to the base. To the base BE. Of the isosceles triangle, triangle ABE, because of the fact that it creates 90 degrees with the base BE. And we have rule number 1. According to rule number 1, the height to the base of an isosceles triangle bisects the base. So actually, according to rule number 1, the height AM to the base BE of the isosceles triangle ABE bisects the base BE. That is to say, it divides it to two equal parts. That is to say, BM is equals to ME according to rule number 1. BM is equal to ME according to rule number 1. Okay, triangle ABE is an isosceles triangle, AM is the height to the base BE, and according to rule number 1, the height to the base is bisects the base, so the height AM to the base BE bisects the base BE, that is to say BM equals to ME, according to rule number 1. So if we define BM as Y, according to our definition, BM equals to Y, then from this equation, Y equals to BM equals to ME, we will conclude that ME is also equal to Y. Okay? So what is the value of side BE of the isosceles triangle ABE? The value of BE, you can see it from the drawing, that BE equals to BM plus ME from one side, but BM equals to Y and ME equals to Y also. Y plus Y is 2Y, so we actually found out that from one side BE is equal to 2Y, but from the other side the value of BE, you can see it from the drawing, that BE is equal to BD plus DE. I'll write it down. BE is equal to BD plus DE. But BD equals to 3 units. It is given us the question. DE equals to 7 units. It is also given us in the question. So BE equals to 3 plus 7, that is 2. So from the other side, BE equals to 10 units. Okay? So from one side, BE equals to 2Y, and from the other side, BE equals to 10 units. So from this equation, 2Y equals to BE equals to 10, we will conclude that 2Y equals to 10. We'll divide this equation by 2 and we'll get that Y equals to 5. Y equals to 5. So actually, BM is equal to Y and Y equals to 5, so BM will be also equal to 5 units, and we also know that ME is equal to Y and Y equals to 5, so ME will be also equal to 5 units. So we can write here that we found out that BM is equal to 5 units, and ME is also equal to 5 units. In the next step, we will focus on the right triangle ABM, and the right triangle AME, and we will prove that those two right triangles can go into each other. Okay? I'll repeat again, we'll focus on the right triangle ABM. And the right triangle MAE. And we will prove that those two right triangles can go into each other. So why those two right triangles can go into each other? First of all, First of all, we know that AB equals to AE according to what is given us the question. AB equals to AE. Okay? AB is equal to AE. Is given us the question, given. And we also know that we just right now proved that BM is equal to ME equals to 5 units. BM equals to ME equals to 5 units. And AM is a common side, it belongs to both triangles, so we can write down that AM equals to AM is a common side that belongs to both triangles. AM equals to AM is a common side that belongs to both triangles. So actually, we proved that the right triangle, triangle ABM, can go into the right triangle, triangle AME according to side rule. I write it down. We proved that the right triangle, triangle ABM congruent, this is the sign of congruent, to the right triangle, triangle AME or MAE according to side rule. Okay? We actually proved that all the sides of triangle ABM can go into all the sides of triangle AME, therefore we proved that those two triangles can go into each other according to side rule. And from the fact that those two right triangles can go into each other, we will conclude that angle BAM of triangle BAM is equal to angle MAE of triangle AME. I will repeat again. We will conclude from the fact that those two triangles can go into each other that angle BAM equals to angle AME according to the rule that corresponding angles in congruent triangles are equal to each other. Those two right triangles can go into each other, therefore the corresponding angles B, that is to say angle BAM and angle MAE, will be equal to each other. Okay? And if we define angle BAM as Z, angle BAM is equal to Z according to our definition. Then from this equation, Z equals to angle BAM equals to angle AME, we will conclude that angle AME is also equals to Z. So we found out that angle BAM is equal to Z and angle AME is also equal to Z. And what is the value of angle BAE? The value of angle BAE from one side it equals to angle BAM plus angle MAE. It equals to angle BAM plus angle MAE. Okay, angle BAE. This angle from one side is equal to angle BAM plus angle MAE, that is actually Z plus Z, that is 2Z. So from one side angle BAE is equal to 2Z, and from the other side angle BAE is equals to theta plus alpha. So from this equation, theta plus alpha equals to angle BAE equals to 2Z, we will conclude that theta plus alpha equals to 2Z. We will divide this equation by 2, and we'll get that angle Z equals to theta plus alpha over 2. Okay, angle Z equals to theta plus alpha over 2. And angle Z equals to angle BAM, so, and angle Z equals to theta plus alpha over 2. That is to say, angle BAM will be also equal to theta plus alpha over 2. And we also know that angle BAM is also equals to, angle AME is also equals to Z, and angle Z equals to theta plus alpha over 2. So angle Z will be, angle AME will be also equal to theta plus alpha over 2. So we can write here the drawing that angle BAM, this angle is equal to theta plus alpha over 2, and angle MAE, that is actually this angle, will be also equal to theta plus alpha over 2. Okay, so in the next step, I will copy the right triangle AME in a new page, and we'll analyze the right triangle AME. You should remember that angle MAE, we just right now proved that it equals to theta plus alpha over 2. Okay, so here angle AME, angle MAE, this angle equals to theta plus alpha over 2. I repeat again, this angle MAE equals to theta plus alpha over 2 according to what we just right now found out. What is the value of ME? ME is equal to 5 units according to what we have already found out. ME equals to 5 units. And we will define AM as edge. AM is equal to edge according to our definition. So we can write here that AM equals to edge. So here tangent theta plus alpha over 2, according to equation number 1, tangent theta plus alpha over 2 will be equal to ME over AM. But ME equals to 5 units. AM equals to edge according to our definition. In conclusion, we found out that according to equation number 1, tangent theta plus alpha over 2 is equal to 5 over h. Okay? Tangent theta plus alpha over 2 equals to 5 over h. In the next step, I will copy the right triangle AMC in a new page, and we will analyze the right triangle AMC. Okay? AM is equal to H according to our definition. What is the value of angle MAC? The value of angle MAC from the drawing, it is very easy to see that the value of angle MAC, it is actually equals to theta plus alpha over 2 plus theta. Again, the value of angle MAC is equal to theta plus alpha over 2 plus theta. I will write it down. It equals to theta plus alpha over 2 plus theta. This angle MAC equals to theta plus alpha over 2 plus theta. What is the value of side MC? The value of side MC, you can see it from the drawing that MC is equal to ME plus EC. MC is equal to ME plus EC. And then side MC is equal to ME plus EC, but ME equals to 5 units and MC equals to X. So in conclusion, we found out that MC equals to 5 plus X. MC equals to 5 plus X, so we can write down here that MC equals to 5 plus X. And we will also found the missing angle ACM, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. And especially in the right triangle AMC, the sum of its angles is equal to 180 degrees, that is to say, and this angle that is actually angle MAC plus this angle that equals to 90 degrees plus the missing angle, the angle that we are looking for, that is actually angle MCA, this angle. In total, the sum of those two angles must be equal to 180 degrees. Here we will subtract 90 degrees from this equation and we will find out that angle MAC plus angle ACM, angle MAC plus angle ACM plus angle MCA angle MAC plus angle MCA, they equal to 180 degrees minus 90 degrees is 90 degrees. Okay, we will subtract angle MAC from this equation and we will get that angle MCA, the angle that we are looking for, is equal to 90 degrees minus angle MAC. But we have already found out that the value of angle MAC equals to theta plus alpha over 2 plus theta. Okay, so here angle MCA, the angle that we are looking for, will be equal to 90 degrees plus the value of angle MAC, that is actually equals to theta plus alpha over 2 plus theta. And we have already found out that 90 degrees is equal to 2 theta plus alpha. Here, from one side, angle BAC equals to 90 degrees, from the other side, angle BAC equals to 2 theta plus alpha. Therefore, we conclude from this that 90 degrees equals to 2 theta plus alpha. We did it and we will not repeat on it. So 90 degrees equals to 2 theta plus alpha. That is to say, we can substitute 90 degrees in this equation by 2 theta plus alpha. We will do it and we will get an angle MCA, the angle that we are looking for, is equal to 90 degrees is 2 theta plus alpha minus theta plus alpha over 2 plus theta. Here we will open the brackets on this side of the equation and we will get that the value of angle MCA is equal to 2 theta plus alpha minus theta plus alpha over 2 minus theta. So here we have 2 theta minus theta is theta. So we get that angle MCA equals to, again, 2 theta minus theta is theta. We have theta plus alpha minus theta plus alpha over 2. So, in conclusion, we found out that the angle that we are looking for, that is angle ACM, equals to theta plus alpha minus theta plus alpha over 2. And theta plus alpha minus theta plus alpha over 2 equals to theta plus alpha over 2. So we actually found out that the angle that we are looking for, angle MCA, is equal to theta plus alpha over 2. So I will draw the right triangle, triangle ACM again, and we'll put the value of angle MCA inside the triangle. We found out that angle MCA, this angle equals to theta plus alpha over 2. We have already found out that MC equals to 5 plus x, and AM equals to h according to our definition. So in the right triangle, triangle AMC, tangents theta plus alpha over 2 equals to MA over MC. That is to say, AM or MA equals to H, MC equals to 5 over X. So in conclusion, we found out that according to equation number 2, tangents theta plus alpha over 2 is equal to H over 5 plus X. Okay? I'll repeat again, according to equation number 2, tangents theta plus alpha over 2 equals to H over 5 plus X. But according to equation number 1, we have already found out that tangents theta plus alpha over 2 is equal to 5 over H. Now we create equation number 3, that is combination between equation number 1 and equation number 2. According to equation number 3, we will get that the value of tangents theta plus alpha over 2 is equal actually to H over 5 over X according to equation number 1. and it is also equals to h 5 over h according to equation. Actually, it equals to h over 5 plus x according to equation number 2, and it equals to 5 over h according to equation number 1. Okay? Equation number 3 is the combination of equation number 1 with equation number 2. In the next step, we will find out the value of theta plus alpha over 2. What is the value of theta plus alpha over 2? The value of theta plus alpha over 2 will be equal to theta plus alpha. We have already found out that alpha equals to 90 degrees minus 2 theta over 2. So here we have 90 degrees and theta plus theta minus 2 theta over 2. So it is 90 degrees over 2 is 45 degrees, and theta minus 2 theta is minus theta. So we have here minus theta over 2. So actually, in conclusion, we found out that theta plus alpha over 2 is equals to 45 degrees minus theta over 2. And we know that if alpha equals to beta, then tangent alpha must be also equal to tangent beta. Therefore, tangent theta plus alpha over 2 must be equal to tangent 45 degrees minus theta over 2. We have trigonometric identity for tangent x minus y, and the value of tangent x minus y, or the value of the trigonometric identity tangent x minus y is equals to tangent x minus tangent y over 1 plus tangent x times tangent y. So we will use this trigonometric identity in order to find out the value of tangent 45 degrees minus theta over 2. The value of tangent 45 degrees minus theta over 2 according to this trigonometric identity will be equal to tangent 45 degrees minus tangent theta over 2 over 1 plus tangent 45 degrees times tangent theta over 2. And we know that tangent 45 degrees is equal to 1, so it is in the numerator we have 1 minus tangent theta over 2, and in the denominator we have 1 plus tangent 45 degrees is 1, so it is 1 plus tangent theta over 2. So in conclusion, we found out that tangent theta plus alpha over 2 is equal to 1 minus tangent theta over 2 over 1 plus tangent theta over 2. Okay? So actually, in order to find out the value of tangent theta plus alpha over 2, the only thing that is left to do is to find out the value of tangent theta over 2. And we actually have trigonometric identity for the value of tangent theta over 2. According to the following trigonometric identity, the value of tangent theta over 2 is equal to sinus theta over 1 plus cosine theta. Okay? And we have already found out that sinus theta is equal to 1 over 3. And we have the trigonometric identity that states that sinus squared theta plus cosine squared theta equals to 1. We will subtract sine squared theta from this trigonometric identity, and we will get that cosine squared theta equals to 1 minus sine squared theta. We take a root from this equation, and we will get that cosine theta is equal to the square root of 1 minus sine squared theta, and we know that sine theta equals to 1 over 3, therefore sine squared theta will be equal to 1 over 9. So we can write here that cosine theta is equal to the square root of 1 minus 1 over 9, that is sine squared theta. 1 minus 1 over 9 is 8 over 9, and the square root of 8 is 2 times square root of 2, and the square root of 9 is 3, so in conclusion we found out that cosine theta is equal to 2 times square root of 2 over 3, and we have already found out that sine theta equals to 1 over 3. Now we can put the values of sine theta and cosine theta inside the trigonometric identity in order to find out the value of tangent theta over 2. So the value of tangent theta over 2, according to this trigonometric identity, will be equal to sine theta, that is 1 over 3, over 1 plus cosine theta, and we already found out that cosine theta equals to 2 times square root of 2 over 3. And here we will multiply 1 by 3, and then we will divide it by 3 in order to have a common factor with this expression, and we will get that 1 over 3 over 3 plus 2 times square root of 2 over 3. Here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled, and we left only with 1 over 3 plus 2 times square root of 3. So in conclusion, we found out that tangent theta over 2 equals to 1 over 3 times 3 plus 2 times square root of 2, and we will simplify this expression. The expression is 1 over 3 plus 2 times the square root of 2. We will multiply this expression by 3 minus 2 times square root of 2, and then we will divide it by the same expression. So here we will multiply this expression by 3 minus 2 times square root of 2, and then we will divide it by 3 minus 2 times square root of 2. So in the numerator we have 3 minus 2 times square root of 2, and in the denominator we have 3 plus 2 times square root of 2 times 3 minus 2 times square root of 2. That is very similar to the algebraic identity that states that a plus b times a minus b equals to a squared minus b squared. Here a equals to 3, so a squared is 3 squared, that is 9, minus b squared. B is 2 times square root of 2, so b squared is 2 times square root of 2 squared, that is actually 8. So in conclusion, in the denominator we have 2 minus 9, that is 1, and in the numerator we have 3 minus 2 times square root of 2. So actually, in conclusion, we found out that tangents theta over 2 is equal to 3 minus 2 times square root of 2. So now we can put the value of tangent theta over 2 inside the equation of tangent theta plus alpha over 2. We have already found out that tangent theta plus alpha over 2 is equal to 1 minus tangent theta over 2 over 1 plus tangent theta over 2. So we'll put the value of tangent theta over 2 inside this equation in order to find out the value of tangent theta plus alpha over 2. So we get here that tangent theta plus alpha over 2, it is actually equals to 1 minus tangent theta over 2, that is equal to 3 minus 2 times square root of 2 over 1 plus tangent theta over 2, that is equal to 3 minus 2 times square root of 2. So here 1 minus 3 is minus 2. Minus and minus is plus, so it is plus 2 times square root of 2 over 3 plus 1 plus 3 is 4 minus 2 times square root of 2. So here we have 2 times square root of 2 minus 2 over 4 minus 2 times square root of 2. From the numerator we will take 2 as a common factor. Inside the brackets we will have square root of 2 minus 1. And from the denominator we will take a common factor of 2 times square root of 2. And inside the brackets we will have square root of 2 minus 1. We have square root of 2 minus 1 in the numerator. We have square root of 2 minus 1 in the denominator. So square root of 2 minus 1 will get cancelled. We have 2 in the numerator and 2 in the denominator. So 2 also will get cancelled. And we left only with 1 over square root of 2. So in conclusion, we found out that the value of tangent theta plus alpha over 2, it is actually equals to 1 over square root of 2. And we have already found out that according to equation number 3, tangent theta plus alpha over 2 is equal to h over 5 plus x. It also equals to 5 over h. And we just right now found out that tangent theta plus alpha over 2 equals to 1 over square root of 2. So from equation number 3, we will derive the equation that 5 over h is equal to 1 over square root of 2. we will cross multiply this equation and we will get that age equals to 5 times square root of 2. In the next step, we will derive from equation number 3 the following equation, that age over 5 plus x is equal to 1 over square root of 2. Again, age over 5 plus x is equal to 1 over square root of 2. We have already found out that age equals to 5 times square root of 2, so we'll substitute age by 5 times square root of 2 over 5 plus x, that equals to 1 over square root of 2. Here we will cross multiply this equation and we will get that 5 times square root of 2 times square root of 2 equals to 5 plus x. Here 5 square root of 2 times square root of 2 is 2, and 2 times 5 is 10, so in conclusion we found out that 10 equals to 5 plus x. We will subtract 5 from this equation and we will find out that x equals to 10 minus 5, that is 5 units. So actually we found out that x, that is also equals to CE, is equal to 5 units. So we can write down here that x, that is equal to CE, is equal to 5 units. So in the next step, I will summarize the lecture. Actually, we have here triangle ABC. And we know that AB is equal to AE. We also know that BD equals to 3 units. DE equals to 7 units. We know that angle BAD equals to theta, angle EAC is also equals to theta, and angle BAC, the big angle, is equal to 90 degrees. And we want to find out the value of line segment EC that equals to x. Okay, so first of all, we defined angle DAE as alpha, and from point A we draw perpendicular to BC. So this angle equals to 90 degrees and this angle is also equals to 90 degrees. And here we defined the touching point of the perpendicular from point A to BC as M. Then we calculated the ratio between the area of triangle BAD and the area of triangle ADE. So the area of triangle ABD will be equal to BD, that is the base of the triangle, times the height to the base, that is AM, over 2. The area of triangle ABD equals to BD times AM over 2 over the area of triangle ADE. The area of triangle ADE equals to the base DE times the height to the base, that is AM, over 2. Here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled and we will left only with BD times AM over DE times AM. AM over AM is 1, so AM will get cancelled. We left only with BD over DE, but BD equals to 3 units, DE equals to 7 units. Okay, so in conclusion, we found out that the area of triangle ABD over the area of triangle ADE equals to 3 over 7. Then we calculated the area of triangles ABD and triangle ADE in a different way. In the second way, the area of triangle ABD was calculated by the base is AB times the height to the base is DO, it gets 90 degrees with the base AB. So from point A we draw perpendicular to AB. This angle equals to 90 degrees and this angle equals to 90 degrees. So DO is the height to the base because of the fact that it gets 90 degrees with the base AB. So we define DO as edge 1. So the area of triangle ABD will be equal to the base AB times the height to the base, that is edge 1 over 2. Again, the area of triangle ABD will be equal to the base AB times the I to the base, that is H1 over 2. Likewise, we calculated the area of triangle ADE in a different way. We took the base as AE, the base is AE, and from point D we drew perpendicular to the base AB. We define the tangent point between the perpendicular from point D and AE as K. So DK is perpendicular to AE, therefore DK is the height to the base AE. So we define DK as H2. So the area of triangle ADK will be equal to the base AE times the height to the base, that is H2 over 2. Okay, the area of triangle ADE will be equal to the base AE times the height to the base, that is H2 over 2. Here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So in conclusion, we found out that AB times H1 equals to AE over AE times H2. Because of the fact that AB equals to AE, it is given us the question, and AB over AE will be equal to 1. So AB and AE will get cancelled, and we left only with H1 over H2. So the only thing that is left to do is to find out the values of H1 and H2. Here, in the right triangle AOD, sinus theta will be equal to H1 over AD. Again, in the right triangle AOD, it is actually triangle AOK, AOD, right triangle AOD, sinus theta equals to H1 over AD. Sinus theta equals to H1 over AD. We multiplied this equation by AD and found out that H1 equals to AD times sinus theta. So we can write here that H1 is equal to AD times sinus theta. Likewise, we calculated the value of H2. We focused on the right triangle ADK. Here, sinus alpha equals to H2 over AD. In the right triangle ADK, sinus alpha equals to H2 over AD. We multiplied this equation by AD and found out that H2 equals to AD times sinus alpha. So we can write here that H2 is equal to AD times sinus alpha. So we have AD in the numerator and AD in the denominator. So AD will get cancelled, and we left only with sinus theta over sinus alpha. In conclusion, we found out that according to equation number 1, 3 over 7 equals to sinus theta over sinus alpha. Then, because multiplied the equation number 1, and we found out that according to equation number 1, 3 times sinus alpha equals to 7 times sinus theta. Then we found out the value of alpha. What is the value of alpha? We know that from one side, angle BAC equals to 90 degrees. And from the other side, angle BAC equals to theta plus alpha plus theta. That is to say, it equals to theta plus alpha. Okay, I'll repeat again. From one side, angle BAC equals to 90 degrees. But from the other side, angle BAC equals to theta plus alpha. From this equation, 2 theta plus alpha equals to angle BAC equals to 90 degrees. We will derive that 2 theta plus alpha equals to 90 degrees. We subtracted 2 theta from this equation and found out that alpha equals to 90 degrees minus 2 theta. Therefore, we can substitute alpha in equation number 1 by 90 degrees minus 2 theta. We did it, and we got that 3 times sinus and alpha is 90 degrees minus 2 theta is equals to 7 times sinus theta. Then we have the trigonometric identity that states that sinus 90 degrees minus x equals to cosine x. And according to this trigonometric identity, the value of sinus 90 degrees minus 2 theta will be equal to cosine 2 theta. That is to say, we can substitute sinus 90 degrees minus 2 theta by cosine 2 theta. We did it, and we got that 3 times cosine 2 theta equals to 7 times sine theta. And we also have trigonometric identity for cosine 2 theta. According to the following trigonometric identity, cosine 2 theta is equal to 1 minus 2 sine squared theta. So we can substitute cosine 2 theta in equation number 1 by 1 minus 2 sine squared theta. We did it, and we got that 3 times 1 minus 2 sine squared theta equals to 7 times sine theta. Then we open the brackets in equation number 1, and we got that according to equation number 1, 3 times 1 is 3, and 3 times minus 2 sine squared theta is equal to minus 6 times sine squared theta, that equals to 7 times sine squared theta. We added to this equation number 1, 6 times sine squared theta, we subtracted 3, and found out that according to equation number 1, 6 times sine squared theta plus 7 times sine theta minus 3 equals to 0. So we have here a quadratic equation, and the missing variable in this quadratic equation is the variable that we are looking for is sinus theta. And the general formula for quadratic equation is ax squared plus bx plus c equals to 0. Here, in this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the value that we are looking for. And we will find out the value of x according to the following formula, that x is equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, the variable that we are looking for x is sinus theta, the coefficient a equals to 6, the coefficient b equals to 7, and the coefficient c equals to minus 3. So we will put the data inside the solution for quadratic equation of the formula for x, and we will find out the value of sinus theta, because x equals to sinus theta. So according to this equation, sinus theta equals to minus b, that is, b is 7, so minus b is minus 7, plus minus square root of b squared. B is 7, so b squared is 7 squared, 7 squared is 49, minus 4 times a, that is 6, times c, that is minus 3. So minus 4 times 6 is minus 24, minus 24 times minus 3 is 72, plus 72. So in conclusion, we found out that inside the root we have 49 plus 72, so it is sinus theta that equals to minus 7 plus minus square root of 49 plus 72 over 2a. 2 times 6 is 12. So we found out that sinus theta equals to minus 7 plus minus 49 plus 72 is 121. So inside the root we have 121 over 12, and the square root of 121 is 11. So we found out that sinus theta equals to minus 7 plus minus 11 over 12. The first solution that is possible for sinus theta is sinus theta equals to minus 7 minus 11 over 12. And the second solution that is possible for sinus theta is that sinus theta equals to minus 7 plus 11 over 12. We will focus on the first solution. The first solution is sinus theta equals to minus 7 minus 11 is minus 18. Minus 18 over 12 is minus 1.5. So sinus theta equals to minus 1.5, but sinus theta can never be equal to minus 1.5 because of the fact that sinus theta can accept values that are ranging only from minus 1 to plus 1. And because of the fact that minus 1.5 is less than minus 1, that is to say, the solution that sinus theta equals to minus 1.5 exceeds the range of values that sinus theta can accept. Therefore, this solution is incorrect solution. We will cancel this solution and we will focus on the second solution, that sinus theta equals to minus 7 plus 11 over 12. Minus 7 plus 11 is 4, as 4 over 12 is, we divide both the numerator and the denominator by 4, and we will get that 4 over 4 is 1 and 12 over 4 is 3. So in conclusion, we found out that sinus theta equals to 1 over 3. Okay, then we focused on triangle ABE because of the fact that in triangle ABE, AB is equal to AE. It is given as the question. Therefore, triangle ABE is an isosceles triangle. Okay, and we have AM. AM is the eye to the, and the base of the isosceles triangle ABE is BE. And AM is the eye to the base BE. Why? Because AM is perpendicular to BE. Therefore, AM is the eye to the base BE. Okay? And we have rule number 1. According to rule number 1, the eye to the base of an isosceles triangle bisects the base. So according to rule number 1, the eye AM to the base BE bisects the base BE. That is to say, BM will be equal to ME. According to rule number 1. And if we define BM as Y, then from this equation Y equals to BM equals to ME, we will conclude that ME is also equals to Y. So BM equals to Y, ME equals to Y. But what is the value of BE? You can see it from the drawing that BE equals to BM plus ME. BE equals to BM plus ME, that is to say BM equals to Y, and ME is also equals to Y, that is to say BE equals to Y plus Y, that is 2Y. So from one side, BE is equal to Y. But from the other side, we know that BE equals to BD plus DE. BE equals to BD plus DE. BD equals to 3 units. DE equals to 7 units. So BE equals to 3 plus 7, that is 10. So from the other side, BE equals to 10 units. Again, from one side BE equals to 2Y, and from the other side BE equals to 10. So from this equation 2Y equals to BE equals to 10, we will conclude that 2Y equals to 10. We divided this equation by 2 and found out that Y equals to 5. So Y is equal also to BM. So if Y equals to 5, then BM is also equals to 5, and ME is also equal to 5. And if Y equals to 5, then ME will be also equal to 5. So we can write here that BM is equal to 5 units, and ME is also equal to 5 units. Okay, then we focus on the right triangle, triangle ABM, and the right triangle, triangle AME, and we prove that those two right triangles can relate to each other. Why those two right triangles can relate to each other? First of all, we know that AB equals to AE. It is given as the question. AB equals to AE, it is given. We just right now found out that BM equals to ME equals to 5 units. BM equals to ME equals to 5 units. And we have here AM, it is a common side that belongs to both triangles. So AM equals to AM is a common side that belongs to both triangles. So therefore we actually proved that the right triangle, triangle ABM can go into the right triangle, triangle AME according to side rule. From the fact that those two right triangles can go into each other, we conclude that angle BAM is equal to angle MAE according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding angles, that is to say angle BAM and angle MAE, will be equal to each other. Okay, so angle BAM is equal to AME. And if we define angle BAM as Z, then from this equation Z equals to angle BAM equals to angle AME, we will conclude that angle AME is also equal to Z. So we have angle BAM that equals to Z and angle MAE that is also equal to Z. But what is the value of angle BAE? The value of this angle BAE, from one side it equals to angle BAM plus angle MAE. From one side it equals to angle BAM plus angle MAE, that is actually Z plus Z. That is to say it equals to 2Z from one side. But from the other side, angle BAE is equal to theta plus alpha. From the other side, angle BAE is equal to theta plus alpha. So we have angle BAE from one side equals to theta plus alpha, and from the other side it equals to 2z. From this equation, we will conclude that theta plus alpha equals to 2z. We divided this equation by 2 and we found out that angle z equals to theta plus alpha over 2. But BAM is also equal to z, and if z equals to theta plus alpha over 2, then angle BAM will be also equal to theta plus alpha over 2. Angle MAE is also equal to z, so if angle z equals to theta plus alpha over 2, then angle MAE is also will be equal to theta plus alpha over 2. So we can write here that angle BAM is equal to theta plus alpha over 2, and angle MAE is also equal to theta plus alpha over 2. Then I copied the right triangle MAE in a new page, and we analyzed the right triangle AME. This is the right triangle AME. We have already found out that ME equals to 5 units. AM is equal to edge according to our definition. And we just right now found out that angle MAE is equal to theta plus alpha over 2. So in the right triangle AME, we can write down that tangent theta plus alpha over 2 equals to ME over AM, but ME equals to 5 and AM equals to 8. So in conclusion, we found out that according to equation number 1, tangent theta plus alpha over 2 equals to 5 over h. Then I copied the right triangle AMC in a new page, and we analyzed the right triangle AMC. Here, this is triangle AMC. AM is equal to edge according to our definition. What is the value of angle MAC? From the drawing, it is very easy to see that the value of angle MAC, it is actually equal to theta plus alpha over 2 plus theta. Again, the value of angle MAC equals to theta plus alpha over 2 plus theta. And so here, angle MAC equals to theta plus alpha over 2 plus theta. And what is the value of side MC? It is very easy to see from the drawing that MC equals to ME plus EC. Again, MC equals to ME plus EC, but ME equals to 5 units, EC equals to X. So in conclusion, we found out that MC equals to X plus 5. So in the right triangle AMC, the missing angle here is angle ACM, and we found out the value of angle ACM according to the rule that the sum of the angles in any triangle is equal to 180 degrees. So in the right triangle AMC, the sum of its angles must be equal to 180 degrees. That is to say, this angle that is actually angle MAC plus this angle that equals to 90 degrees plus this angle that is angle ACM, the angle that we are looking for. In total, the sum of those three angles must be equal to 180 degrees. We subtracted 90 degrees from this equation, and we found out that angle MAC plus angle ACM equals to 180 degrees minus 90 degrees is 90 degrees. We subtracted angle MAC from this equation, and we found out that angle ACM, then the angle that we are looking for, equals to 90 degrees minus angle MAC. So angle MCA equals to 90 degrees minus angle MAC, but we have already found out that angle MAC equals to theta plus alpha over 2 plus theta, so we can substitute angle ACM by theta plus alpha over 2 plus theta. And we have already found out that 90 degrees is actually equals to 2 theta plus alpha, so we can substitute 90 degrees by 2 theta plus alpha. We did it, and we got that angle MCA equals to 2 theta plus alpha, that is 90 degrees, minus theta plus alpha over 2 plus theta. We opened the brackets in this side of the equation and found out that angle ACM equals to 2 theta plus alpha minus theta plus alpha over 2, minus before the brackets, the sign plus will become minus, so it is minus theta. So 2 theta minus theta is theta. And we got the value of angle ACM, the angle that we are looking for, it is actually equals to theta plus alpha minus theta plus alpha over 2, and theta plus alpha minus theta plus alpha over 2 equals to theta plus alpha over 2. So we found out that the angle that we are looking for, angle ACM, equals to theta plus alpha over 2, and we have already found out that MC equals to 5 over x, and AM equals to h according to our definition. So in the right triangle AMC, times theta plus alpha over 2 will be equal to AM over MC. And AM equals to h, MC equals to 5 plus x. So in conclusion, we found out that according to equation number 2, times theta plus alpha over 2 equals to h over 5 plus x. And according to equation number 1, we have already found out that times theta plus alpha equals to 5 over h. Then we created equation number 3, that is the combination of equation number 1 with equation number 2. So according to equation number 3, times theta plus alpha equals to h over 5 plus x according to equation number 2, and it also equals to 5 over h according to equation number 1. Okay? Then we found the value of theta plus alpha over 2. What is the value of theta plus alpha over 2? The value of theta plus alpha over 2 is actually equals to theta, and we have already found out that theta equals to 90 degrees minus 2 theta, so we can substitute alpha by 90 degrees minus 2 theta. We did it, and we got that theta plus alpha over 2 equals to theta plus 90 degrees minus 2 theta over 2. We open the brackets, and we got here 90 degrees plus theta minus 2 theta over 2. 90 degrees over 2 is 45 degrees, and theta minus 2 theta is minus theta. So in conclusion, we found out that theta plus alpha over 2 equals to 45 degrees minus theta over 2. And if alpha equals to beta, then tangent alpha will be equal to tangent beta. Therefore, tangent theta plus alpha over 2 will be equal to tangent 45 degrees minus tangent 45 degrees minus theta over 2. And in order to find out the value of this expression, we will use the trigonometric identity that states that tangent x minus y equals to tangent x minus tangent y over 1 plus tangent x times tangent y. So here, according to this trigonometric identity, the value of tangent 45 degrees minus theta over 2 will be equal to tangent 45 degrees minus tangent theta over 2 over 1 times tangent 45 degrees times tangent theta over 2. We know that tangent 45 degrees is equal to 1, so in the numerator we will have 1 minus tangent theta over 2, and in the denominator we will have 1 plus tangent theta over 2. So in conclusion, we found out that tangent theta over 2 equals to 1 minus tangent theta over 2 over 1 plus tangent theta over 2. So the only thing that is left to do in order to find out the value of tangent theta plus alpha over 2 is to find out the value of tangent theta over 2. And tangent theta over 2, we have trigonometric identity for tangent theta over 2. According to this trigonometric identity, tangent theta over 2 equals to sinus theta over 1 plus cosine theta. And we already found out that sinus theta equals to 1 over 3. And we have the trigonometric identity that states that sine square theta plus cosine square theta equals to 1. We subtracted sine square theta from this equation and found out that cosine square theta equals to 1 minus sinus square theta. We took a root of this equation and found out that cosine theta equals to the square root of 1 minus sine square theta. We know that sinus theta equals to 3, so sinus square theta will be equal to sinus theta equals to 1 over 3, so sinus square theta will be equal to 1 over 9. So we can put the value of sinus square theta inside the root. So cosine theta will be equal to 1 minus sinus square theta, that is 1 over 9. 1 minus 1 over 9 equals to 8 over 9, and cosine theta equals to the square root of 8 over 9. The square root of 8 is 2 times square root of 2, and the square root of 9 is 3. So in conclusion, we found out that cosine theta equals to 2 times square root of 2 over 3, and we have already found out that sinus theta equals to 1 over 3. So now we can put the values of cosine theta and sine theta inside the trigonometric identity for tangent theta over 2. So tangent theta over 2 will be equal to sinus theta, that is 1 over 3, over 1 plus cosine theta, that is 2 times square root of 2 over 3. Here we multiplied 1 by 3 and then we divided by 3 in order to have a common factor with this expression. And we found out that 1 over 3 over 3 plus 2 times square root of 2 over 3 equals to, here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled and we left only with 1 over 3 times 2 times 1 over 3 plus 2 times square root of 2. So we found out that in conclusion tangent theta over 2 equals to 1 over 3 plus 2 times square root of 2. We simplified this expression, that is actually 1 over 3 times square root of 2, by multiplying it by 3 minus 2 times square root of 2, and by dividing it by 3 minus 2 times square root of 2. So in the numerator we have 3 minus 2 times square root of 2, and the denominator we have expression that is very similar to the algebraic identity that a plus b times a minus b equals to a squared minus b squared. Here a equals to 3, so a squared is 3 squared, 3 squared is 9. B equals to 2 times square root of 2, so b squared is 2 times square root of 2 squared, that is 8. So in conclusion, in the denominator we have 9 minus 8, and in the numerator we have 3 minus 2 times square root of 2. So in conclusion, we found out that the value of tangent theta over 2 equals to 3 minus 2 times square root of 2. Now we can put the value of tangent theta over 2 inside the equation for tangent theta plus alpha over 2. According to the equation of tangent theta plus alpha over 2, it equals to 1 minus tangent theta over 2 over 1 plus tangent theta over 2. And here we got the tangent theta over 2, tangent theta plus alpha over 2 equals to 1 minus tangent theta over 2, that is 3 minus 2 times square root of 2, over 1 plus tangent theta over 2, that is actually equals to 3 minus 2 times square root of 2. Here 1 minus 3 is minus 2, minus and minus is plus, so it is minus 2 plus 2 times square root of 2, and here we have 1 plus 3 is 4, minus 2 times square root of 2. So we have here 2 times square root of 2 minus 2 over 4 minus 2 times square root of 2. We took 2 as a common factor from the numerator, and inside the brackets we have square root of 2 minus 1. And from the denominator we took 2 times square root of 2 as a common factor, and inside the brackets what is left, it is actually square root of 2 minus 1. So we have square root of 2 minus 1 in the numerator and square root of 2 minus 1 in the denominator. So square root of 2 minus 1 will get cancelled. We have 2 in the numerator and 2 in the denominator, so 2 will also get cancelled, and we left only with 1 over square root of 2. That is to say, we found out that tangent theta plus alpha over 2 equals to 1 over square root of 2. Now we have equation number 3 that states that tangent theta plus alpha over 2 equals to edge over 5 plus x, that equals to 5 over edge. And we just right now found out that tangent theta plus alpha over 2 is also equals to 1 over square root of 2. Okay, so from this long equation, equation number 3, we derived that 5 over edge equals to 1 over square root of 2, because multiply this equation, and we found out that edge equals to 5 times square root of 2. Then from this long equation, equation number 3, we derived the equation that edge over 5 plus x equals to 1 over square root of 2. And here we have already found out that edge equals to 5 times square root of 2, so we can substitute edge by 5 times square root of 2. We did it, and we got that 5 times square root of 2 over 5 plus x equals to 1 over square root of 2. We cross multiplied this equation, and we found out that 5 times square root of 2 times 1 times square root of 2 equals to 5 plus x. So here we have square root of 2 times square root of 2 is 2, and 2 times 5 is 10. So in conclusion, we got that 10 equals to 5 plus x. We subtracted 5 from this equation, and we found out that x equals to 5 units. So here, x that equals to CE, or x that equals to EC is equal to 5 units. So the answer to the question that the value of line segment X that is also equals to EC is equal to 5 units. Okay, thank you very much.